Good morning, dear students. Today class we will discuss about Quicksort. In the last class we have discussed about Morsort. Actually, we are discussing the algorithm to solve using divide and conquer approach. In the last class we have solved algorithm of Morsort using divide and conquer approach, and there we have seen that for Morsort we require theta of n log n time to sort n elements. Now today we will discuss about Quicksort. Okay, as we have know, in divide and conquer approach, the first is divide, then conquer, then combine, Okay, hence in case of your Morsort, what we have done? We have divided in equal parts. If an array of n elements, we are dividing n by 2 for the left sub-array and n by 2 for the right sub-array, and we are solving. But in Quicksort, the division is something different. That means if you have given if you are given an array A, we will partition into two sub-arrays. See, we are partitioning into two sub-array A q minus 1 and A q plus 1 r. That means we are sorry, here it is q minus 1, not q minus 1. Now what is happening? Once an array A is given, what will happen? We are finding an element whose position is say q, or an element which is called q, and we are placing this element. We are finding an element or choosing an element which is called a pivot element, and we are placing in a position whose position is q, such that the elements left of it is less than equal to the pivot element, and the elements right of it is equal to the pivot element. Now we are sorting using the same Quicksort to the left elements, and we are sorting the same element with using Quicksort. We are sorting the right elements using the same Quicksort. Hence, in this case, the main designing approach is the divide. Divide the array. We are getting an element called pivot element and dividing the array into two sub-arrays, such that the left sub-array is less than equal to the pivot element and the right sub-array is greater than equal to the pivot element. Now then conquer. Conquer means in this case what happens? We are recursively sorting the left part sub-array and the right part sub-array using the same Quicksort. That means again it will go on dividing until we are getting in each sub-array a single element which is by default sorted. And then we are doing combining. Combine in this case, since the element are placed in its array, and the combining is trivial. That means by default it is combined, because once and combining is trivial and requires no time. Hence, let us see the Quicksort algorithms. That means initially, if an array is given, p is equal to 1, because from the 1 index, and r is equal to n, because initially if you want to sort an elements, n elements, its index from start a to n. Now in this case, this is the checking for the what is base case. If p is less than r, means there is at least two elements are there. Then find a partition algorithm, employ a partition algorithm where q means partition algorithm to find a position q such that it will be divided in two parts. One is your a p q minus 1, and another is your a q plus 1 and r, and in between there is a element whose position is q, such that this element is less than, as I have already told, less than this element where it is in the position q, and this element, this array is greater than element to the element which is called where in the position q, and this element is called pivot element. This element is called pivot. Now apply the quicksort for the left subarray and apply the quicksort for the right subarray, and combinations to the left solution of the left subarray and solution to the right subarray is trivial, because if it is sorted and if this is sorted, then definitely the whole array will be sorted. Hence, no need to combine as happened in case of your merge sort, because the left subarray is always less than equal to the right subarray. Hence, no need to merging or the combining as happened in case of merge sort. Hence, in this quicksort algorithm, the main part is your partitioning. Hence, let us see the partitioning algorithm. This is the partitioning algorithm. See, in this case, what happens? This is the partitioning algorithm. What is happening? Suppose you want to partition the array A, the P initial index, R is the final index given. And in this case, X is equal to AR. X is equal to AR. That means the pivot element is chosen as the last element. The pivot element is chosen as the last element. Hence, what happens? In this case, I is equal to P minus 1. Where I will point to, initially I will point to here. And that means just this position I is pointing. And J will point to, initially J will point to here. J for P to R minus 1. That means J will be pointing here, and at the end it will go to J value. J value will point to here, and at the end it will go to here. Sorry, not here. It will go to J minus 1 here. Okay, and then that means J from P to R minus 1. And that means inside the for loop, once J will reach to R minus 1, that means this position, then only our algorithm of partition will end. Then inside this for loop, what is happening? Do if Aj is less than equal to X. If Aj is less than equal to X. Now what is the X here? In this case, X is equal to your pivot element AR, which is equal to 4. Now what is the Aj? Aj is equal to 2. Hence the first case, while for J is equal to P. P means here J is equal to P. That means J is pointing to, in this case, here. Hence, in this case, J is pointing to, that means Aj is your Aj is 2. And Aj is less than equal to X? Yes, Aj is less than equal to X. Then I is equal to I plus 1. Then what will happen? I will point to, what is? I will point to here. Because I was pointing here, I will point to here. Now what happened? Exchange AI with Aj. Exchange AI with Aj, because in this case, what is? J is pointing to, what is? J is pointing to the first element, and I is pointing to, hence exchange of itself will be taken place, and 2 will be exchanged with itself. Hence in this case, next J will point to what? Next element. That means here J will point to here. J is pointing to here. Now I is pointing to here. See, initially what happens? I was pointing to here, J was pointing to here, and your X is equal to 4. And in that case, Aj is equal to 2, which is less than equal to X. Hence, what is happening? I is pointing to more 1, and you are exchanging. Exchange AI with Aj. That means exchange 2 is exchanging with 2, and now J is pointing. J is equal to, that means again we are doing J is equal to P plus 1, and J is pointing to here. Now in this case, what is your Aj? Aj is 8, and is less than equal to 4. No, it is not satisfying. Then what will happen? Again what happen? Your J will be next, because J will be increased. In this case for loop, in this for loop J will be increased, and again what is Aj is equal to J? Aj is 7. Your Aj value is 7. Hence what happens? Is this less than equal to 4? No. Hence again J will be point to the next element here. That means your Aj in this case is 1, which is less than equal to 4. Yes, this is satisfying. That means this condition is satisfying. Hence I is equal to I plus 1. Then what will happen? I is here. That means I is here. In this case, now I will be this, come to here, and exchange AI with Aj. What is the AI value here? AI value is 1, and Aj value is, AI value is 8, and because I will point to here, AI value is, and Aj value is 1. Hence these two will be exchanged. These two will be exchanged, which we are getting this. That means 1 will go to here and 8 will go to here. that means 8 will be. Now what happens in this case, again j will be increased, but after exchanging j will be increased, and j is pointing to here. Now what is your aj value? Aj value is equal to 3. Is it less than 4? Yes. Then in that case what happen? Again I will be increased, that means I will go to here, and your these two things will be interchanged. That means then 3 will be go to here, and again j will be increased. That means 3 is going to here, and j value will be. Now again in this case aj will be what? Aj will be 5, which is less than or equal to 4. No. Hence what will happen? This exchange will never not taken place in this case. Again j will be 5. Okay, j will be 6. J will be 6. Aj will be 6. That means aj will be 6, which is less than or equal to 4. Hence the exchange will not taken place. Now and that means after this what happens? And the for loop here, the for loop ends, because the for loop will be j from p to r minus 1. Here the for loop ends. After ending the for loop, exchange ai plus 1 with ar. That means what is your I is this. That means I is this. I plus 1 is your what is 8. 8 with ar. Ar means 4. That means these two things will be exchanged. After exchanging, this will happen. Now return I plus 1. Return I plus 1. That means q will be your I plus 1. That means this will be q, because you know we have called q is equal to partition A P R. We have written in the Quicksort algorithm in the past. You see, in this case q is equal to partition A P R. Hence in this case what happens? This will be q, because this is I plus 1 return q. Now hence this is divided into two parts. That means partitioning what happens in case of if you are calling Quicksort with A R P. Now what happens? If this is the array, is given. Now this is the array is given where the elements are 2, 8, 7, 1, 3, 5, 6, 4, 3, 5, 6, 4. Now this is divided into two parts. This is to divide. One part is your what happens, that is 2, 1, 3. Other part is your, though it is we are not employing, that is your this is your q. That means it is value is 4, and other part is your what happens? This is 7, 5, 6, 8. Okay, that means these 4. Now again this is by default sorted, because this 4 element, which is the position of q, is by default sorted, and now that means these n elements is divided into here. That means some elements, some part, and here to some part, and that means n sorting problem is now reached to n minus 1 sorting problem with two parts, because this one is already sorted, two parts. Now in the same case we will partition this. That means for this case we will consider 3 as the pivot element. Hence what will happen? This will be again divided into, in this next part it will be nothing will be there, because here it will be what is 2, 1, and here it is 3, which is the position of q, but we are not considering it, and the right part is empty here, because nothing will be there. And in this case we will consider 8 as the pivot element, and it will be divided as 7, 5, 6, like this, and the right part is empty. 8 will be there, but it is by default, it is the position, it is not the right part. Now in this part is empty, because no element is there which is greater than 9. In this case no element is there which is greater than 3. Now in this case we will consider the pivot element as this, and this will be divided into 2. And in this case we will consider the pivot element as 6, and this will be divided into two things, what is 5 and 7. 5 and 7, but the middle element 6 is by default sorted. It is not the part of the next recurrence. Okay, that means again we will combine 5, 6, 7, then what is 2, and 1 will be there, 1 will be here now, because it is by default sorted. That means what happens in this process? What happens? In the combining is very simple, 5, 6, 7. Hence in this case what will happen? It will give 5, 6, 7, this part. Now this part will give 1, 2, 1, 2. Now here 1, 2 will come. Okay, 1, 2 will come. Now 1, 2 will combine with 3 because here 3 is by default sorted, hence it will be 1, 2, 3. Now these two things is by default combined. That is because combination is very simple. No need to do anything in combination. Hence this is the algorithm for quicksort. Hence in quicksort main part is the dividing and partitioning. And in this case we have followed the partitioning where we have taken the last element as the pivot element. Now the question is that why we are taking the last element is the pivot element. It is no, you can take any element as the pivot element. Someone can take the first element, this element as pivot element. If you are taking this element as the pivot element, then accordingly this partitioning algorithm will change. This is not the this will not be the partitioning algorithm. You will change the first element as the pivot element. Someone can check that I will take the middle element as the pivot element, not the first or last element. That if you choose the middle element as the pivot element, then accordingly this partitioning algorithm will change. The partitioning algorithm will change. If you are taking middle as the pivot element, this type of partitioning is called horror partitioning. In the textbook exercise, that is called horror partitioning. Accordingly, the partitioning algorithm will change. And in this case, we have written the partitioning algorithm where we have taken the last element as the pivot element. Okay. Hence, in the if you are whatever may be the pivot element you are taking, but the partitioning in the aim of partitioning is that left of the pivot, what are the elements we will that means pivot element we will keep in its proper position, and whatever the element left will be left of the less than equal to the pivot element will be the left sub array, and whatever the elements which is greater than equal to the pivot element will be on the right sub array, and the pivot element is placed in its proper position. That means its position is fixed. That means it is in its position. No need to change. It is if you will sort the elements, the pivot element is we are choosing and partitioning. That means we are placing the pivot element in its proper position. Okay, and now we will consider what is the time complexity of this partitioning algorithm. Now for this what will happen? It will take C constant time. This will take constant time. This is what? This is a for loop. How many times the for loop will run? For loop will run n. This is the n plus 1 time into say C. This is n time into C. This is n time into C. This is also exchange will be at max n time into C will happen, and this is what is it? This is the last exchange, that means C, and this is C. That means it is of what is theta of n, because this for loop is dominating the partitioning and is theta of n. The partitioning algorithm time complexity is theta of n, or you can say Cn, the partitioning time complexity. Hence, now the situation is arising here, as we told. Then how, if you depending on the pivot, choosing the pivot element, the partitioning may happen that suppose this is the array. That means it may happen as we have seen in this example. Some array contains element and the other part, right part, may not contain any element, and it may happen that left can contain the all the n-1 element, and the right part does not contain any element, and the pivot element will be there. Okay, see what I am saying. Suppose you are calling quicksort with n elements. It may happen that n-1 element will be on the left part, and the pivot element will be in its proper position, and in the right part no element will be there. Okay, the same thing also happen in case of that in the left part there may be no element, and in the right part the pivot element will be there, and in the left part there is no element, and in the middle the pivot element will be there, and the right part, right subproblem, because this is the left subproblem, this is the right subproblem. In the right part exactly n-1 elements will be there. This may happen that, or it may happen that the pivot element will be placed in its proper position, and in the left part there will be n by 2 elements. Actually it will be n-1 by 2, and the other part it will be n by 2 element. That means it is equally divided, leaving this pivot element. The remaining element will be equally divided. It may happen, and it may happen that the pivot element will be placed in this position, and the left element will be maybe n by 9 times, and the right may be what is 8n by 9 times, or it may be that it is n by 10 times, it may be 9n by 10 times. It depends how the partitioning happens. Okay, that means because it is not the exact n by 2 partitioning, because we are choosing the pivot element, accordingly we are partitioning, and the how many elements in the left or how many elements are at the right will be taken is not fixed, in this partitioning. Many situations may come in the partitioning. Hence, accordingly, what is the time complexity of quicksort will change. Hence, what is happening? Worst case. In worst case, what is happening? That means we are calculating the time complexity of quicksort. Hence, in worst case, what will happen? That means if you are calling a quicksort with n elements, now it may happen that first time it will be this is the pivot element, and the right will be n minus 1 element, and left will be 0 element, no element. And it may happen that left will be n minus 2 elements, and here it is the pivot element, and in the right it will be no element. That means what happens? Every time if you are calling Tn, then it will be Tn minus 1. That means one part will be there with, and no other part will be there. That means if the sub problem is divided in such a way that only one part contains the whole, the one sub problem will contains n minus 1 elements, because the pivot element is by default not considering any of the sub problems. Hence, in this case, what will happen? The recurrence relation will be Tn is equal to Tn minus 1 plus n or Cn. What is this? This is the time complexity for partitioning. Time complexity of partitioning. If this is the case, then what will be the case? Then you can write Tn is equal to n minus 1 Cn. Again, you can write Cn plus Tn minus what? For this, what we can write? Cn minus 1 plus Tn minus 2. In this way, we can write, if this is the way the partitioning happens in every time in the quicksort. But reality, it doesn't happen. In the worst case, we are thinking that if the partitioning happens like this in every case, then what happens? Which is again equal to what happens? Again Cn, that means plus Cn minus 1 plus Cn minus 2 into plus Tn minus 3. If in this case it will happen, then what happen? At finally, what we can write? Tn is equal to what is Cn plus C into n minus 1 plus 1 plus T1. Like this we will write. That means every time, okay. In this way, hence what will happen? It is nothing but the summation over C summation over n from 0 to n or 1 to n, whatever may be. Hence it will be what is C into n into n plus 1 by 2. Hence which is equal to what is theta of n square. Hence the time complexity of quicksort in worst case is theta of n square. See, here we have, hence this is the time complexity of quicksort in H, which is equal to theta of n square, as we have told, because the tree will be like this. Now let us consider the best case. Best case means if the situation happens that it is exactly divided into two parts. This situation. That means every time we are calling the quicksort, it is this part is n by 2 elements, this part is not exactly but approximately n by 2 elements, leaving the pivot element. If this is the case, you can write Tn is equal to 2t n by 2 plus theta n. And you can use the master theorem to solve this, or you can use the recurrence tree. You can use the recurrence tree to solve this problem. See, in this case, as I have told, this will be Cn, means you can write this is Cn, or you can write it in simply n, and this is n. Again, it will be Tn by 2, Tn by 2, because this is for Tn by 2, and Tn by 2 will be again divided into Cn by 2 plus Tn by 4 and Tn n by 4 because following the same recurrence relation, and hence Tn by 4 again can be replaced as n by 4 into Tn by 8, Tn by 8, and Tn by 8 it again can be divided. Like this, if is the case, and in this level, how many? What is the cost? It is n. In this level, n by 2 and n by 2, the cost is n. In this level, n by 4, n by 4, n by 4, n by 4, the total cost is n. Like this. If the size is exactly divisible by 2, if the size is exactly divisible by 2, that means if n elements will be there, the height will be log n, as we have already told. The height will be log n. If the height will be log n, there will be how many levels? Log n plus 1 levels. Hence log n plus 1 levels, and each having size what? N. Hence the time complexity will be what is? Log n plus 1 into n, which is equal to theta for log n, which is equal to theta of log n. Hence the time complexity of Quicksort in its best case is theta of log n. Now, if it is not the worst case or not the best case, suppose it is the average case. Average case, suppose it may happen that Tn will be T9n by 10 and Tn by 10 plus n. And this is the partitioning, the time complexity of partitioning. Now, in this case, it will be n. Now, the left will be 1/10 of the array and the right will be 9/10 of the array. In this case, we will go. Now, you see, this is the this part. That means in the last one, this part, the height of this, the level of the left root, the left branch, level of the root, left branch is log, what is, log n 10, because this level, this the rightmost level, sorry, this is Tn, not Qn, Tn. Okay. Now the left level is what is terminating quickly, but that means it will come 1 too quickly, and that means this left leave of the left level, the height of the height of the left level, that from this to this is log 10 plus 1. And from this to this, up to this, it is log n with it base 10 by 9. Okay. Now, in this case, if you will add this is n. This case, this will be n. This will n. But in some time after this level, this will be less than n. This will be less than n. Is this clear? This will be less than. Hence, if we will consider only the longest path, suppose we will consider the longest path, this will give us what is, if we will consider the longest path, then this is the longest path. Hence, longest path height is log 10, log n to the base 10 by n. Longest path height. This is, in this case, if you will go to the longest path, its label will be log n 10 by n plus 1. But in the shortest path, the label number of labels will be log n, what is 10 plus 1. Hence, in the longest path, it will be the maximum time complexity, which is equal to if you add this, then what happen? This into maximum n. Okay, hence it will be, and if you take n together, it will be the summation of 1 log n. And in this case, what will be? This is the log n plus 1, and this is the time complexity of in the longest path. Similarly, for the shortest path, sorry, it is not Qn, it is Tn. Tn will be, what is happening? In this path, it will be also n greater than or equal to this in the shortest path, and it will be also C a log n. Hence, in both the cases, sorry, this is Tn, not Qn. In both the cases, whether longest path or shortest path, the time complexity is n log n. The time complexity is n log n. Hence, in the average case, the time complexity of Quicksort is n log n. Okay. Hence, we are concluding here that we have discussed the Quicksort, and we have seen that we are choosing a pivot element. pivot element, last element we have chosen the pivot element and partition the element around the pivot element, so that the element which is left to the pivot element is less than equal to the pivot element, and element which is right side of the pivot element is greater than equal to the pivot element. This way we are partitioning, and the pivot element we are placing its proper position. That means in the after the sorting, the pivot element position will not be disturbed. And in this way partitioning is taking place, and then again we are quick sorting the left sub array following the same algorithm, and again we are sorting the right sub array following the same quick sort algorithm, and this way, and the combining the solutions of sub problems, solution of the sub problems in case of quicksort is easy. It doesn't happen in case of your merge sort, where we are merging the solutions. Okay, now in this way the sorting is taken place. Now pivot element can be taken as last element, it can be taken as first element, or it can be taken as the middle element, or it can be taken, pivot element can be taken every time randomly. If you are taking pivot element every time randomly, this is called randomized quicksort, where the algorithm we are not discussing here. Okay, now for the partitioning algorithm, whether you take any way of pivot element, it is of theta of n, or the time taken will be order of n. Now once the partitioning is done, hence we can calculate the time complexity of quicksort, and there are three parts of calculating the time complexity of quicksort. That is worst case. Worst case means every time the partitioning happens, so that one part of the partitioning contains no element. That means in this case Tn will be Tn minus 1 plus Cn. If this is the case, then the time complexity will be theta of n square. But other in the best case, when it will divide into equal two parts, then it will be theta of n log n. In the average case, or the not in between worst and best case, that means the average case, this will be also as shown in the figure, this will be also the time complexity is your theta of n log n. Hence this quicksort algorithm I am ending here.